Yes, we now come to the next method of solving a DE after the exact DE. So the second one is the linear DE, so linear differential equation. So as you all know, linearity means it refers to the degree called 1. We'll see now what is this linear differential equation. So the concept will be the same. So a differential equation of the form, if you are writing in a particular form like dy by dx plus p of x means a function of x into y is equal to one more function of x named as q of x. So if our dE is written like this, that means you are able to take dy by dx separately and you are able to have a y term which is multiplied with a function of x, and you are left with a term which is only a function of x which is pushed to the other side. So if your dE is written particularly in this format, then the name given to this is linear differential equation in y we call. So where p of x and q of x are functions of x. So you can see here the degree of dy by dx and the degree of y, that is particularly I am telling about the dependent variable. So dependent variable is y, right, which is in the numerator. So the power of y and dy by dx will be 1. That is also one of the thing to take care. And one more thing is y and dy by dx will not be multiplied together. See here, there is no term called y into dy by dx. So apart from this particular format, I am just giving you two more hints like the power of dy by dx and y must be 1, and y into dy by dx, you cannot see such type of term. And if it is written in this format, it is said to be linear differential equation in y. So it is not always in y, we can also have in x. That is what the next format written. It's a dx by dy plus p of y into x is equal to q of y. Just reverse of the previous, changing the variables x and y. So it is called linear differential equation in x. Same way we can have in other variables. See here we have written dx by dt. So it's not always y term only present or x term only present in particular places. So we can have some different forms. See, if you see the third one, dx by dt written. That means x is the dependent variable, t is the independent variable. See, in general, we have almost many problems wherein the independent variable is time. So which is taken as a t. That's why the dx by dt terms will arise. So all these three examples, whatever the examples means the format of the d is written are in terms of t. But the numerator variables are different. The first one is in x, second one is in y, third one is in u. So these all formats tells you that it is linear in x, it's linear in y, it's linear in u, right? So, but the independent variable is a t here. So just to take care of the notation what it is used. Whatever is in the numerator, that is only the name given there, right? We will see now how to solve this type of Ds. And it's very, very important in our engineering mathematics to understand and be perfect with this linear differential equations. Why? Because many of the engineering problems in the real situations will be converted as linear differential equations only. That's why better to concentrate more in your future problems also about this linear differential equations. We have told no the same thing we have written here. Linear in y means there should be terms y and dy by dx present, and p of x, q of x will be functions of x but not functions of y, and multiplication of y with dy by dx should not be there. That's what I have mentioned. And the coefficient of dy by dx must be 1. That means we are starting with the dy by dx. Once again written the same thing, linear in y. So dy by dx plus p of x into y is q of x. This is called linear in y. Now it's very simple for this to write the solution. It's only 2 steps. The first step is we will write the integrating factor. Integrating factor is a helping factor to write the solution. It is e power integral p dx. So just take off p and q from the given dE if you recognize it as linear dE. Then the first step is first write down a helping factor called if, means integrating factor. It is e power integral p dx. After finding this integration, we can write the solution directly. So what is the solution? It is y into integrating factor equals to integral of q into integrating factor, then integral with respect to x, that is dx, plus a c as an integration constant. So better to memorize this. It's because of all the theory, all the integration and all procedure done, and we are giving you directly the solution how to write. So it is y into integrating factor is equal to integrating of the q into if dx plus c. So here what we have done is we have multiplied the integrating factor for the given dE and we have integrated. But all the procedure is not shown to you. It is just the final format given to you. So just remember this for the problems. Same way, if it is linear in x, but the independent variable is a t, then how to write the solution is mentioned here. So dx by dt plus p of t into x equals to q of t. It is called linear in x. Okay. Then what is the solution is? Just the variables are different, that's it here. There it was dy by dx, here it is dx by dt. So the solution goes the same. X into if is equal to integral q into if. Because they are functions of t, it is into dt plus c. So like this, we will mention all the different linear in y, linear in x, and written the solutions, how to write the solution, just to know the format. Need not be confused. Just you can learn one linear in y perfectly. Then whatever is given, you can just introduce with that. See here it is dx by dy. Then you have tried the solution in terms of x into if. So like that. If you see the next one, dy by du. That means solution will be written in terms of y and u. So y into if is integral q if into if with respect to u plus c. So like that, whatever the problem is, depending on that, we have to write. So we'll see now one question. Solve x plus 1 into dy by dx minus y equals to e power 3x into x plus 1 whole square. So by seeing a differential equation, this is an example of a d because dy by dx is there. So immediately we cannot come to a conclusion. Slowly we have to observe and find it, like to which method it falls. If we observe, it is close to the linear. Why? Because dy by dx, okay, it is not directly in the form of the standard form, but x plus 1 into dy by dx is there still. But slowly if you observe, second term is y and dy by dx is there. They are not multiplied together and degree is 1 and right hand side only function of x. So why can't we try it with linear is what your mind should say. So like that, by observing, we can see that, okay, x plus 1 is not supposed to be there, but it is there. So why can't we divide it and see is what the trial we can start. So just divide by x plus 1 throughout the equation. See, the next step, what happened? dy by dx minus 1 by x plus 1 into y equals to e power 3x into x plus 1. Just dividing that by x plus 1, it immediately fall into the linear in y. So just pick out p of x and q of x from the problem. P is minus 1 by x plus 1. Q is e power 3x into x plus 1. Then according to the procedure, it is only the two steps. First one is if integrating factor and second one is directly writing the solution. So what is if? E power integral p dx. It is e power integral minus 1 by x plus 1. So integral of minus 1 by x plus 1 is minus log of x plus 1. That is minus log x plus 1 is log x plus 1 power minus 1. It is a logarithm property. Log a power m is m log e. Then e power log no. So we'll get only x plus 1 power minus 1. E power log x is x. That's why it will come only x plus 1 power minus 1. So final answer is 1 by x plus 1. So we will say that general solution is, what is the general solution? Y into integrating factor equals to integral of q into integrating factor dx plus c. So y into 1 by x plus 1 equals to integral q is e power 3x into x plus 1 into if is 1 by x plus 1 dx plus c. So x plus 1 cancel, integral e power 3x is e power 3x by 3. That's it. Plus c gives the solution. So if we recognize it as a particular type, we are done with the solution. So we have to just observe 1 or 2 minutes, like it can be done with which method. Like that, many problems we have to discuss. So solve x square dy by dx plus y equals to 1. If you observe here, y and dy by dx are not multiplied together and the degree is 1, right? So why can't we try with linear in y? It's a trial. So but dy by dx is with x square. So let us divide this by x square and see. So once we divide it, the next step you can see that it is in the form of dy by dx plus y into function of x is equal to function of x. So with a small exercise that what we have done is dividing by x square, it is to this form. So with this we will come to know that it can be done with linear. So pick out p and q from the equation. P is 1 by x square, q is 1 by x square. Then only 2 steps to go. One is integrating factor, e power integral p dx. So e power integral 1 by x square, that is e power minus 1 by x. Then what is the solution directly? So y into if is integral q into if dx plus c. So what is if? E power minus 1 by x we got. Just replace them. What is q, what is y, all that. Then integral of what we need to do is 1 by x square into e power minus 1 by x. So here e power minus 1 by x is there. So better to have a substitution method whenever we have such type of functions of x in that e power. So taking minus 1 by x as t, then the differentiation of minus 1 by x is 1 by x square dx is dt. So what will happen? Integral 1 by x square e power minus 1 by x can be written as just integral e power t. So integral e power t is e power t. So what is t that we took? Minus 1 by x. So replacing that minus 1 by x back, we'll get the integral of 1 by x square e power minus 1 by x is just e power minus 1 by x. So without using all that Bernoulli's principle or integration by parts, it's a substitution method which is very easy for you. Okay, that's it. Plus c, integration constant c. So this way we have finished our problem easily. So like that, many problems you can see. See, even this problem is direct. So dy by dx plus y secant x equal to tan x. This problem is direct. See, it is in the form of dy by dx plus a function of x into y equals to function of x, where the function of x p is secant x and the function of x q is tan x. So it's a direct form of linear in y. So we are done, that's it. So we can write what is if and what is the solution. So integrating factor is e power integral p dx. P is integral secant x. So integral secant is log of secant x plus tan x. So e power log of will be only that function called secant x plus tan x. So what is the general solution? Y into if is integral q into if dx plus c. So if you see the integration, so tan x into secant x plus tan x into tan x is tan square. So what is the integral of this? Integral secant x tan x is secant x. And integral of tan square x is not direct. So we search for an easier method. We can write tan square as secant square x minus 1. And now integral of secant square x is tan x. And integral of minus 1 is minus x. So like that we can make our integration simpler. So like this, we can do number of problems. So you can see next problem, x plus y plus 1 dy by dx is 1, right? So from here, we just do a trial whether it can be linear in y or linear in x. See, by writing x plus y plus 1 is equal to 1 by dy by dx, suppose we got dx by dy. Then just shifting the terms, all y terms here, all x terms here, is it possible for any linearity? If we have like that type of intention to do, just we will try. So by trying that, we got it called dx by dy minus y equal minus x equals to y plus 1. So it is exactly in the form of linear in x. It's not always the same linear in y. Sometimes it can be written in this format also. We have to try. So it is linear in x. That means dx by dy plus p of y into x is q of y. So here p of y is minus 1 and q of y is y plus 1. That's it. After recognizing this, the two steps are what is the IF and what is the solution. So IF is e power integral p dy we call, because it is linear in x, so the variables will change. Integral e power, it is e power integral p dy we should do. So p is minus 1. See here it need not be function of y, means we need not search for function of y. Even 1 also a function of y only. If you see in the equation, there is no y present here. Even then also it can be considered, because a constant also a function of y. Because here q also function of y, here the constant also function of y. That way it is considered. So now e power integral minus 1 is e power minus y and the general solution. It's very easy to finish the answer. So like this we can do and try with the linear if it is possible. See, y square is there here and plus x minus 1 by y dy by dx is there. So can it be considered as linear in y or not? If we check, means, see, y square term exists, 1 by y exists. So it cannot be linear in y is one of the hint. But x term is there and it is of first degree, then we can have it as linear in x. That is also one of the hint. Like when we do more number of problems, we can see this type of observations. So now this problem can be done easily in terms of dx by dy. Okay, so like that we'll try the problems. So dx by dy and the function of x into the, that is x into function of y is equal to function of y. Are you able to write? Yes, we are able to write. So it can be solved with linear in x. Same way, next problem, 1 plus y square dx tan inverse y minus x dy. See here x is with dy. X power is 1. If it is with dy, means definitely it can be solved with linear in x. Like that, one hint. So same way, one more equation is given. Dy by dx plus 3x square y is like this. Dy by dx is there, okay. Y into function of x is there, correct. Right hand side also function of x. Then it is directly in the form of linear in y. So we can solve it. So few problems will be direct, few will be indirect. So this problem also can be solved with the help of substitution method. So we can do it. See, there are so many problems are there. You can just try with the same, and problems are directly given. So we can copy these problems and try for it. Since we are doing under this, it can be either linear in y or linear in x problems. But in the exam, we need to observe for 1 or 2 minutes and then come to a conclusion like we can do by this method. Or else it can be the trial method called, okay, let us see first it is variable separable or not, then go with the exact. If it is not, then let us think of linear. So like that, like priority wise also we can check. Or if we are having a good observation of having, it can be definitely in linear in y or linear in x, like that also we can proceed. So but finally definitely there will be a solution with any one of the methods, or sometimes all the methods also will give the solution. So definitely every DE will be solved by any of the methods. So like this, many problems are selected and listed here. So you can go through them, you can practice. So these are the problems.